Hey guys, hope you're doing well today. Happy Tuesday. I hope you guys are in for some good learning now, as we're about to do a new lesson here in Pre-Algebra. This is section 6.6, solving two-step inequalities. All right, so in case you forgot what an inequality was, it's a statement that compares using less than, greater than, less than or equal to, or greater than or equal to these symbols right here. All right. So in solving two-step inequalities, it's very similar to solving a two-step equation. First, you want to undo addition, subtraction. Then you want to undo multiplication and division. All right. One new thing, well, not really new, but one thing different than regular equations is that occasionally you have to flip the inequality when you multiply or divide both sides by a negative, and that's only for multiplying and dividing, okay? So let's look at an example here of a two-step inequality. So we have to try to get x by itself. 9 plus 3x is greater than 27. All right, so first you want to undo addition or subtraction. So you're looking at the term that doesn't have the variable. It's 9. So to undo the 9, you're going to subtract 9 from both sides. Okay, so make sure you remember to show your work. You guys should get a piece of paper when you're doing your homework to write down your work on. Subtract 9 from both sides. Then you're going to bring down the 3x on this side. So you have 3x is. Now, do we flip when we are dividing? No. Do we flip when we are subtracting by 9? No, you don't flip when we were subtracting by 9. We don't ever flip when we were adding and subtracting. So it's still going to be greater than. 3x is greater than 27 minus 9, which is 18. Okay, so we got 18 here. And then we have 3x is greater than 18. To get x by itself, undo 3 times x by dividing both sides by 3. Okay, and then do we flip when we divide by positive 3? Nope. Remember, you flip when you're dividing or multiplying by a negative. So it's going to be x is greater than 6 for this one. All right, let's check out this next one. All right, so once again, undo the plus or minus first. The minus 4 is further away, so we're going to add 4 to both sides first. Okay, and if we add 4 to both sides, we'll get negative 2x is less than or equal to 16. Now, to get rid of the negative 2 times x, we're going to divide both sides by negative 2. And when we divide both sides by negative 2, now we will flip our inequality. So less than or equal to becomes greater than or equal to. So we have x is greater than or equal to negative 8. All right. What we're going to do now is check out a few problems from the book. These are the pages it's on. You could always look also at examples 1 and 2. I'm not going to go over them because you can just read them in the book, but we're going to look at the try it problems here real quick. Okay, I'm going to actually start with example 3, which you can actually look at the book too, but I want to explain it for you a little bit. Okay, so here you have a very similar two-step equation, but this time there's a fraction involved. So once again, you're going to start with the term that doesn't have the variable, the negative 10. To undo a negative 10, you're going to add positive 10. Okay, and since we're adding, you don't flip it for adding and subtracting, so we're not going to flip it. All right, so now you're going to bring down the negative 9 halves x. Okay, and it's going to be less than 90. All right, now think for a second how to get rid of that fraction, negative 9 halves. All right, to get rid of a fraction that's times a variable, you multiply by the reciprocal. So the reciprocal of negative 9 halves is negative 2 ninths. So you're going to multiply both sides by negative 2 ninths. And look what happened when you multiply both sides by negative 2 ninths. This less than became a greater than, okay? And you see, they even flipped it when they showed that they were multiplying both sides by negative 2 ninths. So technically, you should flip it as soon as you show that extra multiplication of a negative, the inequality sign changes. So less than became greater than. All right, let's look at another one kind of similar to this one. All right, so here, same idea. This time, though, you have a positive 5. So to get rid of a positive 5, you need to subtract 5. All right, so we're subtracting 5 from both sides. bringing down what we have left on the left side, which is negative a half x, and it's greater than 25. Now, if we want to get rid of that fraction, we need to multiply by the reciprocal. Flip it, and we need to use a negative to cancel a negative. So we're going to multiply by negative 2 over 1 to both sides. Okay, negative 2 over 1. All right. Now, right now, as soon as we multiply by that negative 2 over 1, this inequality sign is technically flips, okay? So I'm not going to erase it, but really at this step here, it's now switching to become a less than sign. Okay, so negative 2 cancels negative a half, and you're just left with x on this side. So you have x is less than 25 over 1 times negative 2 is just negative 50 over 1, or just negative 50. Okay, so that's how you would handle ones that have fractions that are multiplied by a variable. Let's look at a couple word problems here. Now, make sure you look at the word problems in the book, examples 1 and 2. These are just some try it ones to go along with it. All right. Erin has $52 to spend at the florist. She wants to buy a vase for $11.75 and several roses for $3.50 each. What are the possible numbers of roses Erin can buy? All right, so she's buying a vase. She's only buying one vase. So that is a number that doesn't have a variable. Okay, so that's just $11.75. All right, she's buying several roses for $3.50 each. So the roses is your variable because you don't know how many she's buying, okay? We're going to try to figure out how many roses she can buy. What are the possibilities? So 350 times r, each, remember, multiply. And what sign do we put here? Do we put equal 52? Well, she doesn't have to spend all $52, okay? So we want to make sure that she doesn't go over it, so we're going to use less than or equal to 52. All right, so then you would solve this two-step. You would subtract 1175, so you would have 350 r, and if we subtract 52 minus 1175, we would have, let's see what that would be, 52 minus 1175. It should be able to do that one mentally, but let's just double check here. 4025. Okay, so we have 350r is equal to 4025. Okay, and then we divide by 350. And do we flip it here? Nope, because we're dividing by a positive. All right, so don't flip it when you're dividing by positive. So you got r is less than 1150. Okay, now is that $11.50? No, that's not 1150. Remember, R is for roses. So, how many roses can she buy? She can buy up to, do you round that up to 12 roses? If you round it up to 12, she won't have enough money. So you want to actually make that into 11 roses so she does have enough money. Okay, so you don't want to increase it because that would mean that she would be over $52 because you increase the number that you got, which is 11.5. So you actually want to decrease it. All right, let's look at the next word problem here. The jazz band needs to raise at least $600. I don't know why I'm reading it like that. Okay, to travel to an upcoming competition. The members of the band have already raised $350. If they sell calendars for $8 each, how many calendars would they need to sell to exceed their goal? All right, so we're looking for the number of calendars. So I'm just going to, throw my variable out there. C is equal to the number of calendars. All right, I probably should just type this. It might be easier. Okay, C equals number of calendars. There we go. So let's see what our inequality would be. All right, so it is $8 each for the calendars. So that'd be 8C, okay, because you remember each is multiplying. And they have already raised $350. So you're going to add what they've already raised to this. And so this represents how much money they've raised. Okay, you got 8 times C plus $350, and they need to get at least $600. So since it's at least, you want to be more than it, okay, or equal to $600. So there is your inequality. And you're just going to do a two-step to solve it. So first step, subtract 350, okay? Undo the plus with the minus, okay? Subtract 350. All right, if we subtract 350 from 600, you're going to be left with 250, okay? So we got 250. So we have 8c is greater than or equal to 250. All right, I should have kept on typing here. Anyhow, next step, undo the multiplication with division. Divide both sides by 8. Okay, let's see, what do we get? C is greater than or equal to 850 divided by, or 250 divided by 8. Okay, let's see what that is. That's 31 and a quarter. Okay, 31.25. So, how many calendars do they need to sell? Well, you might think, oh, I'm just going to round this down to 31. Okay, you have to make sure to understand you want to exceed your goal. If you round it down to 31, you're actually going to be a couple dollars short of your goal. So you want to sell number of calendars more than 32. Okay, so to conclude this problem, I would say you need to sell at least 32 calendars. And so that's the way I would write it on my test, because I want to be clear to answer the question, not just some number that means who knows what. Okay, hopefully that makes sense to you guys. If you still are a little leery, I'm gonna also post another video that has some good examples from someone else, but you don't have to watch it if you are good after this. All right, well, hope you have a great Easter, and God bless you guys. We will see you soon. Take care. Bye-bye.